We propose NeCo, a novel training loss that enforces patch-level nearest neighbor consistency across a student and teacher model, relative to reference batches. This method leverages a differentiable sorting method applied on top of pre-trained representations, such as DINOv2, to bootstrap the learning signal and further improve upon them. Our approach improves dense self-supervised learning by directly applying nearest neighbor consistency to patch features, enhancing in-context scene understanding and stabilizing training. We demonstrate that this method generates high-quality dense feature encoders and establish several new state-of-the-art results across various models and datasets. Despite requiring only 19 GPU hours, our method outperforms previous methods by 4% to 13% on in-context segmentation benchmarks. The paper presents a novel method for enhancing the feature space in self-supervised learning, focusing on the concept of patch neighbor consistency. It begins by applying two augmentations to an input image, creating two different views, and then extracting dense features from these views using a teacher-student framework. The features are aligned using ROI aligned to ensure spatial alignment. The paper then computes pairwise distances between the features and a set of reference features, obtained by applying the student network to other images in the batch. These distances are computed based on cosine similarities and are sorted in a differentiable manner to maintain the order of nearest neighbors across two views. This is achieved through a soft, differentiable version of the swap operation, which facilitates gradient propagation. The sorting process involves a permutation matrix Q, which represents the probability distribution over possible sequence elements. By forcing similarity on the order of nearest neighbors for each aligned patch feature, the method enforces a consistent order across the two views, resulting in a more robust and meaningful feature representation. This is achieved via cross-entropy loss that computes the similarity between the permutation matrices Qs and Qt for the student and teacher features, respectively. In summary, the proposed method aims to improve the feature space in self-supervised learning by leveraging patch neighbor consistency. It uses a teacher-student framework, ROI aligned for spatial alignment, and differentiable sorting to maintain the order of nearest neighbors across two views. This approach encourages more robust and meaningful feature representations, which are crucial for various applications in computer vision. The research paper discusses a novel method for ensuring robust nearest neighbor consistency in dense self-supervised learning. It proposes a cross-entropy loss function that computes the loss in both directions between student and teacher features, ensuring consistency in the order of nearest neighbors. The method is evaluated against state-of-the-art dense self-supervised learning methods and unsupervised semantic segmentation approaches. The paper also demonstrates the versatility of the proposed method by applying it to 5 different pre-training models and evaluating the transferability of the learned dense representations to other datasets. The results show that the proposed method outperforms prior state-of-the-art methods in both in-context scene understanding and frozen clustering-based evaluations, particularly in data efficiency regimes. This improvement is attributed to the explicit enforcement of patch-level nearest neighbor consistency, resulting in higher quality patch-level representations. The research paper discusses the NeCo method, which significantly improves linear segmentation and semantic segmentation performance by leveraging frozen clustering and linear segmentation heads. It starts by presenting the performance of different methods on various datasets, highlighting the superiority of NeCo over other approaches. The paper then delves into the compatibility of NeCo with differently pre-trained backbones, demonstrating its ability to enhance the performance of methods designed for dense tasks. The evaluation of full fine-tuning with the segmenter further solidifies NeCo's position as a state-of-the-art method, outperforming Cribbo by approximately 4%. Ablation studies are also conducted to examine the essential parameters of the method, including patch selection approaches and the role of a teacher network. The results show that selecting patches from both foreground and background yields the best performance and that utilizing a teacher network can significantly improve the results. Overall, the paper showcases the effectiveness and versatility of the NeCo method in various segmentation tasks. In this paper, the authors present a novel method for dense post-pretraining of self-supervised backbones, leveraging patch nearest neighbor consistency to improve upon existing models in frozen clustering, semantic segmentation, and full fine-tuning. The proposed approach uses a teacher-student architecture with a sorting algorithm to enhance the learning process. The authors conduct an ablation study on various key parameters, including patch selection, the use of an EMA teacher, nearest neighbor selection, and the choice of training dataset. The results indicate that selecting patches across images consistently boosts performance by roughly 0.4% to 1% across different metrics. The study also shows that the proposed method demonstrates robust performance across different sorting algorithms, achieving the best results with botonic sorting. The paper further discusses the broader impact of their method, highlighting its potential to reduce the carbon footprint of model training by leveraging pre-trained models. It spurs further research into post-pretraining methods, which could significantly contribute to more sustainable AI development. The authors provide a comprehensive list of references, including works on self-supervised learning, visual transformers, and sorting networks. They also detail the significance of their approach in relation to previous studies, emphasizing its improvements and novel contributions to the field. This research paper delves into the realm of object-centric learning, focusing on unsupervised semantic segmentation and localization. The authors explore a novel approach that leverages self-supervised object-centric representations to achieve state-of-the-art results in various benchmarks, including Pascal VOC 2012 and COCO-Stuff. They also provide insights into the role of context for object detection and semantic segmentation in the wild. The paper begins by discussing recent advancements in contrastive learning, which has shown promising results in self-supervised learning of visual representations. It highlights the importance of context and object-centric learning, emphasizing that understanding the relationships between objects and their environment is crucial for effective segmentation and localization. The proposed method utilizes a two-stage pipeline consisting of pre-training a vision transformer with masked image modeling and fine-tuning on object-centric tasks. This approach allows the model to learn robust object-centric representations that can be used for both segmentation and localization without additional annotations. The authors employ several techniques to enhance the performance of their model, such as using a combination of different masking strategies during pre-training, applying object-centric augmentation during fine-tuning, and leveraging a global context module to improve object localization accuracy. Experiments are conducted on various datasets, including ADE20k, Pascal VOC 2012, and COCO-Stuff, demonstrating the effectiveness of the proposed method compared to existing state-of-the-art models. The paper also explores the limitations and potential future directions for object-centric learning, emphasizing the need for further research on handling complex scenes and improving the efficiency of current methods. In conclusion, this paper presents a novel approach to unsupervised semantic segmentation and localization, leveraging self-supervised object-centric representations. By utilizing contrastive learning and contextual information, the authors achieve state-of-the-art results in various benchmarks, contributing significantly to the advancement of object-centric learning in computer vision. The research paper discusses the implementation details of an experimental setup for dense post-pretraining, including the use of Torch and PyTorch Lightning for the model implementation. The datasets used consist of COCO and ImageNet 100, with specific data augmentations applied. The network architecture employs vision transformers, and a student-teacher setup is used. The projection head consists of 3 linear layers with a Gaussian error linear units activation function. Dense image representation alignment is applied to bring local and global crop feature maps to a fixed spatial resolution. Optimization is done using a cosine learning rate schedule, and the atom optimizer is used with a cosine weight decay schedule. The evaluation setup involves a retrieval-based scene understanding evaluation, using the dense nearest neighbor retrieval evaluation, which assesses scene understanding capabilities. The final results are reported as mean intersection over union, MIOU, on various fractions of datasets like Pascal VOC 2012 and ADE20k. Other experiments include overclustering, linear segmentation, and segmenter fine-tuning, all focusing on scene understanding and semantic segmentation. The CD metric leverages local CO occurrence statistics among clusters to identify and categorize objects without labels. It utilizes an information theoretic definition of network communities. Our configuration for CD evaluation remains the same as in Leopard. We use the implementation from Leopard and apply CBFE and CD on the non-augmented split of Pascal VOC 2012, evaluating on its full validation set. The best results are achieved with parameters. Weight_threshold equals 0.07, Markov_time equals 1.2, and K_community equals 189. The contribution of each component to the final clustering evaluation gains is shown in Table 1b. Starting with our method NeCo, applying clustering-based foreground extraction, CBFE, and finally community detection, CD, we observe that CBFE provides the largest boost due to high-quality overclustering maps. CD contributes a modest increase, and combining both results in a significant improvement, bringing the overall gain to 55.1%. In Table 7, we show full clustering results applying various clustering granularity KISS to spatial features from different feature extractors on 2 datasets. The resulting cluster maps are matched to the ground truth by Hungarian matching, and the intersection is reported in MIOU. This comprehensive comparison demonstrates the effectiveness of our method in enhancing dense representations for scene understanding. The evaluation of key parameters for our method involves training a linear layer on top of frozen representations or using in-context evaluation on validation images for Pascal VOC 12 and ADE20k. We analyze the impact of various parameters such as the number of neighbors, batch size, and training epochs. The results show that increasing the number of neighbors and batch size generally improves performance, while the optimal number of training epochs depends on the specific task. Additionally, we provide a detailed runtime analysis for several methods, highlighting the computational efficiency of our proposed method, NeCo, which can enhance the performance of state-of-the-art methods with significantly less training time. Visualizations are provided to illustrate the effectiveness of our method in nearest patch retrieval, clustering, and overclustering, demonstrating its ability to accurately identify and segment objects in images. The research paper discusses the nearest patch retrieval results between NeCo and DINOv2's on Pascal VOC. It highlights how NeCo retrieves more relevant and precise nearest patches, accurately identifying patches within the same object and object parts. This is demonstrated in Figure 4, showcasing the effectiveness of NeCo in this task. However, Figure 5 indicates that NeCo sometimes retrieves patches of similar parts from different objects, such as a bicycle wheel and a motorcycle wheel, due to the cropping method used. This can lead to unexpected nearest neighbors, as seen in the case of the sheep photo. The paper emphasizes the importance of understanding these borderline cases to improve the model's performance and robustness. The visualization in Figure 6 demonstrates the performance of DINOv2's and NeCo on Pascal for k equals 100. NeCo exhibits a more precise localization of objects with tighter boundaries, showcasing its superior performance in object segmentation. Figure 7 presents fully unsupervised segmentation results on Pascal for k equals 21, utilizing the CBFE plus CD method as outlined in 1. This approach involves extracting foreground masks and then clustering them into the number of objects present in the Pascal dataset, which is 21 in this case. As shown, NeCo yields distinct and accurate segmentation maps for each object, highlighting its effectiveness in unsupervised segmentation tasks. These results underscore the capabilities of NeCo in object localization and segmentation, particularly when compared to DINOv2's. By providing more precise boundaries and accurate segmentation maps, NeCo demonstrates its potential for improving various computer vision tasks that rely on object detection and segmentation. The use of the CBFE plus CD method in Figure 7 allows for the extraction of foreground masks, which are then clustered into the appropriate number of objects. This process showcases the versatility of NeCo in handling different stages of image processing, from object detection to segmentation. In conclusion, the presented figures emphasize the strengths of NeCo in both object localization and segmentation tasks, especially in comparison to DINOv2's. Its ability to provide precise boundaries and accurate segmentation maps makes it a promising tool for enhancing various computer vision applications. The authors present a comprehensive overview of the datasets utilized in their research, focusing on 5 prominent datasets in the field of computer vision. Firstly, the Pascal VOC 2012 dataset is introduced, comprising 10,582 images with 21 classes, including a background class. The validation set consists of 1,449 images, and the authors ignore unlabeled objects and the boundary class. They also employ the PVOC-12 train split with 1,464 images for hyperparameter tuning of the fully unsupervised segmentation method. Next, the Pascal context dataset is described, which includes 4,998 training images covering 60 semantic classes, including the background. The validation set consists of 5,105 images, and the authors utilize this dataset for the linear segmentation and segmenter experiments via the segmentation library. The COCO-Stuff 164K dataset is also explored, featuring labels across 91 stuff categories and 80 things categories. The training set comprises 118,000 images, and the validation set contains 5,000 images. The authors extract stuff annotations, consolidate the 91 detailed labels into 15 broader labels, and assign the general label, Other, to non-stuff objects. Non-stuff objects are ignored during training and evaluation. Additionally, they extract foreground annotations utilizing the panoptic labels and combine the instance-level annotations into object categories, consolidating the 80 detailed categories into 12 broad object classes. Furthermore, the ADE20k dataset is introduced, featuring finely detailed labels across 150 unique semantic categories, including stuffs and distinguishable objects. The dataset includes 20,210 images in the training set and 2,000 images in the validation set, making it one of the most challenging and diverse datasets for scene understanding. Lastly, the authors describe the ImageNet dataset, a large-scale visual database designed for visual object recognition research, containing over 1.3 million images categorized into 1,000 object classes. They also explored training on part of the ImageNet, the ImageNet 100K, which consists of 100K images across 100 classes from the original dataset. These datasets are utilized in various experiments, including overclustering and linear segmentation, and the authors provide a detailed explanation of the preprocessing steps and modifications made to each dataset to suit their research requirements.